Okay, we're gonna keep going here with a couple examples. Basically, these are just solving. The only little addition we may have is say whether it's conditional, say whether it's identity, or say whether it's a contradiction. We're gonna get that based on our final answer. Just a reminder: distribute here. 6x minus 6 plus 4 equals 21x plus 3. I know this is really basic, but I'm telling you, I just watched an entire test of pre-calc students mess up on basic stuff. Just simple errors were what driving people down. Just make sure you take your time, watch your negatives when you're supposed to subtract and add and everything else. Combine our x's, get them on the same side, and we're going to get negative 2 equals 15x plus 3. Subtract negative 5 equals 15x. Divide and you get x equals negative 5/15, or x equals negative 1/3. Not too surprising there. Because there's only one number that works, this is called conditional. We're going to skip number, no, we're going to go over number 2. Number 2 is a good example. We're going to distribute to get 2x plus 6 plus x plus 1 equals 3x minus 12 plus 19. Combine our like terms. 3x plus 7 equals 3x plus 7. And wait a minute, if we keep going, if we subtract 3x from both sides, if we subtract 7, we're going to get back to that 0 equals 0, which is what we're talking about. Once we know that, that's an identity. No matter what value we always put in, it's always going to work. This is an identity, and we can say our solution, thus, is the set of all, oh, that's real bad. Let's try it again. The set of all x such that x is contained within the reals. That just means it's every single real number. C and D end up being pretty much more the same thing except for fractions. We'll run through C real quick. D is not a great example. You can try that one if you want. Ends up being C is 1/3 R minus 2 when once you distribute that 1/3 to the 6 plus 4, which equals 1/9 R plus 4. Combine our like terms. 1/3 R plus 2 equals 1/9 R plus 4. When we combine our like terms again by subtracting 1/9 from 1/3, we get 2/9 R equals 2. Divide by 2/9, or you can multiply by the reciprocal of 9/2. See, the 2 goes away, and we get R equal to 2. That also means that this is a conditional equation. There's only one condition that can make it true, therefore it's conditional. The last thing I want to show is it says solve t equals 4x plus r plus 2y plus r for the variable r. This may look tough to begin with, but if you remember that there's an r in both of these, so we can factor it out, we're left with 4x plus 2y, and we can divide to get to get r equals t divided by 4x plus 2y. We solve for the variable. Some teachers may want to have you say something like solve for x and y so your denominator is not equal to 0, but in this case we're just asking for the given variable and solving for r.